Alright, you guys, so we are still in relationships among inscribed angles, radii, and chords. Looks like we're talking about central and circumscribed angles. Well, we learned what a central angle was in the last little tutorial. We also learned what an inscribed angle is. An inscribed angle is an angle that's sitting on the circle, and a central angle is when its vertex is at the center. Circumscribed angles, I guess we're about to learn what those are. All right, so let me click on my GeoGebra. Okay, I got another blank one, so I guess I'm going to have to create a circle here. All right, so let's see here. Follow the steps to create a diagram. Okay. Create points A, B, and C in order on a horizontal line with a distance of 4 units between successive points. Okay. A, B, C, horizontal, 4 units in between. All right, so let's do this. There's A. 1, 2, 3, 4 would be B. 1, 2, 3, 4 would be C. And that's a horizontal. Horizontal is laying down flat. Okay, so draw a circle with center A that passes through B. Let me do that first. Draw a circle through center and point A to B. All right, got that. Draw 2 tangents to the circle passing through C. 2 tangents through the circle to the circle passing through C. All right, so that's come over here to the 4th icon, select tangents. You're going to click on C because it said to go through C. Click anywhere on the circle. Oh, wow, look at that. That is very cool. So this is one tangent because it hits down here. This is the other tangent because it hits up top. Okay, very cool. All right, part 3. Locate the points of intersection of the tangents with the circle and label them D and E. All right, so I come over here, and I need to do an intersect. I need to intersect that tangent with the circle right here, and this tangent with the circle right there. All right, so I did an intersection. If you've been watching my videos, we've been doing this for a while now. All right, draw the radii AD and AE to create a central angle. All right, so I need a segment AD, and a segment AE. All right, here's my central angle. All right, so here is what a circumscribed angle is. It's an angle on the outside. So this is a circumscribed angle, angle DCE. This angle right there, that's a circumscribed angle. So you got a central angle, you've got a circumscribed angle. All right, here's an inscribed angle because it's an angle on the circle. This is also an inscribed angle. And we already know what the measures of angle D and angle E are. Remember, when a radius and a tangent intersect, they form a 90-degree angle. So this angle right here is 90. This angle right here is 90. All right, so this is a circumscribed angle. All right, well, let me see what I got to do with it. Take a screenshot of your construction. Oh, okay, well, I'm not doing anything with it right now. So let me take a screenshot. Whoop, bam. Let me input that. Screenshot. There we go. And let me hit submit. Okay, so that's what theirs looks like. That's what mine looks like. Same thing. Question number 2. Use GeoGebra to record the measure of angle EAD. They want A because that's the letter in the middle. EAD. Okay, that's the central angle they're looking for. So come up here to your angle icon. Remember, you got to go in a right circular motion. So you got to click on E first, then A, then D. So it looks like I got 120 degrees. Let me move that so I can make sure. Yeah, I got 120 degrees. All right, so also find and record angle ADC and AEC. You don't need GeoGebra to find ADC and AEC. Explain why not. All right, so where's ADC? Oh, okay, well, I just said that. Angle D, it's a 90-degree angle automatically. I had no clue that's what they were going to ask you guys. But that's the reason because a radius and a tangent line intersect, they form a 90-degree angle. Here's another radius and another tangent line, they form a 90-degree angle. All right, so let me put in my information. Angle EAD was 120. Angle ADC is 90. And the last one is angle AEC, also 90. Because a radius and a tangent line are perpendicular. All right. Tangent perpendicular, radius, tangent line, ba-boom, got it. All right, question 3. What kind of polygon is bounded by the line segments passing through A, D, C, and E? What is the sum of the interior angles measures of the polygon? Well, A, B, C, and D. So not B. What was it? A, B? A, D, C, E. A, D, C, E. Well, it's a quadrilateral. It's not a rectangle. It's not a rhombus. It's not a square. It looks like a kite, to be honest with you, because you know AD and AE are going to be the same. They're both a radius. Tangent DC and tangent EC are going to be equal because those are your tangents meeting at the same point C. So it looks like a kite, but I'm going to call it a quadrilateral, and the sum of any quad is 360 degrees. Not sure if that's what they're asking. Let me see. Okay, so yeah, it's a quad 360. Okay. Question 4. Use your answers in question 2 and 3 to calculate angle ECD, the circumscribed angle of circle A, and show your work. All right, so I'm looking for ECD. I'm looking for this, what we call a circumscribed angle. All right, well, I already know that D is 90. I know that A is 120. I know that E is also a 90. So the fastest way is to take 360, subtract the 3 that you have. What you're going to have left over is angle C. That's probably the fastest. So 90 minus 120 minus the other 90. I'm going to need my calculator here. 360 minus 90 minus 120 minus 90 equals, looks like my angle is going to be 60 degrees. Yes, it is. Look there, 60 degrees. All right, question number 5. What is the sum of ECD and EAD? ECD and EAD. I can tell you right now, 120 plus 60 is 180. You guys, they will always add up to be 180. A central angle and a circumscribed angle will always be 180 degrees together. 120 plus 60 equals 180 degrees. All right, in GeoGebra, display the measure of the circumscribed angle ECD. All right, so they want me to find that angle and show it. So I'm going to come over here to angle. And remember, you got to go in a right circular motion. That means you got to click on D, then C, then E. Let me move that so you guys can see it. So it's a 60. So 120 plus 60 is 180. I have a feeling they're going to make me manipulate and show that it's 180 every single time. Circle location, C, ECD, 85 different sets. Yeah, that's what they're going to do. All right, so let's move it out. So, I'm going to move somewhere nice. Doesn't look like I'm going to get it nice. That's unfortunate. I was hoping to get nice numbers. Well, that's nice enough. All right, so A is 97.8. C, 82.2. You add those together, you're going to get 180 degrees. In fact, you're going to get that 180 for all of them, y'all. Every single one. All right, so let me move it. Whoop! All right, so 66.96. And angle A, 113.04. All right, boom. How about 52.78? And a 127.22. Add those together, you get 180. All right, bam. How about 45.9? 134.1. Add those together, you get 180. All right, last one, 42.65. 137.35. Add those together, you get 180. Oh, nice. They come out with nice numbers. Yeah, okay, whatever. All right, move point B back to its original position, 4 units from A. So 1, 2, 3, 4. Oh, just let me undo. It'll be a lot easier. All right, there we go. Cool. Back to the original. All right, move point C around the coordinates little plane without crossing the circle. Find in 5 different. Really? I just did that. What did they ask me to move up here? Oh, I moved the wrong one. Oh, this one I'm going to move B. All right, so wiggy, 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 woo, 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 woo. That's pretty cool looking. Wah, 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 woo, 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 woo. Easily amused, you guys. I'm such a nerd. All right, so you get the same thing. You guys can see they're 180. They're 180. 180. 180. 180. 180. 180. All right. So skipping this one because I just did it by accident up here. All right, question 8. Based on your work for question 5 through 7, what conclusion can you draw regarding the circumscribed angle and the central angle that intercepts the same arc? They are supplementary. They are supplementary angles. That means they have to be 180. So same arm, 180. Supplementary. All right, self-evaluation. Go me. I'm submitting. All right, you guys. Basically, though, there is a takeaway from this. You do need to take away that an inscribed angle, my bad, a central angle and a circumscribed angle are going to add up to be 180 degrees all day, every day.